and welcome to the Stellar News. I'm Ian Claire.
And I'm Nelly Jean Bulasong. And today, we will bring you the latest updates from the world of science, space exploration, and beyond. Have you ever wondered how ancient astronomy studies the cosmos without the technology? How do they observe heavenly objects and provide explanation without the advance of technology we have today?
To start interviewing question, Nelly, the ancient astronomers such as Tycho Brahe relied solely on his naked eyes and a set of indigenous instruments to explore the mysteries of the universe. And now we have reporter Lance in NASA to interview some astronomers to further explain to us what instrument does Tycho Brahe use in observing the various objects in the sky. Reporter Lance, are you there?
Yes, Miss Nelly and Erin, I'm here reporting in NASA with NASA astronomer, and we're here with astronomer
Corey A. Pilapi, astronomer Malaika Angel S. Hera.
Okay, astronomer Kepler, can you introduce to us who is Tycho Brahe?
Absolutely. So this is Tycho Brahe, born in 1546. He was a Danish astronomer considered the last great naked eye astronomer. He built his first astronomical and alchemical laboratory named Hirenborg on the island of Ben between Denmark and Sweden.
We heard Brahe's observatory was equipped with a range of instruments that allowed him to make precise observation of celestial objects. Can you introduce to us the instruments created by Tycho Brahe?
So, this is one of Brahe's notable instruments he created. It's called Brahe's azimuthal quadrant. He created this in 1576 at Ben. This device enabled Brahe to measure the altitude and azimuth of celestial objects, such as stars and comets. It played a crucial role in his observation of the 1577 comet. Another remarkable instrumental created by Brahe is the Great Globe. Constructed in 1580, this device served both as a computation tool and record-keeping device. It helped Brahe calculate celestial position and meticulously document the position of stars. This instrument, Brahe also designed and built armillary sphere. He created in 1581. This model consisted of a spherical framework of rings centered on Earth, presenting the position of celestial objects. And let us not forget the triangular system created by Brahe in 1582. This instrument allowed to measure the angular position of celestial bodies relative to the horizon.
Thank you for introducing to us the remarkable instruments of Tycho Brahe. Tycho Brahe is indeed an impressive astronomer in this time for creating those remarkable instruments. So right now, we're here with astronomer Ahara again. Astronomer Ahara, can you introduce to us the contribution of Tycho Brahe in astronomy?
Brahe's contribution to astronomy were nice. He made the most precise observation of his time, revolutionizing astronomical instrumentation. His extensive data collection, particularly on the position of Mars, proved crucial to his research assistant Johannes Kepler to formulate the first law of planetary motion. He also observed the supernova in 1572 and a comet in 1577. Using his instrument to establish the fact that these two bodies were above the moon, Tycho Brahe made the best measurement for stellar parallax, but he also found out that there is no parallax. However, he concluded that the Earth was motionless at the center of the universe, or the stars were too far away that the parallax was too small to measure. He also the first astronomer to make connection for astronomic refraction, the change in direction of a ray of the light as it passes from the space into the atmosphere.
We heard Brahe proposed 3 models. What are they?
Yes, Brahe proposed 3 models. Titanic planetary model, also known geoheliocentric, where the Sun and Moon orbiting the Earth, while the other planets orbiting the Sun. It was the intermediate to Ptolemaic or geocentric, where the Earth and the one-centered of universe. And lastly, the Copernican, also known heliocentric model, where the sun is the center of the universe. However, among the three models, Brahe hired Kepler to mathematical calculation that will prove this model that the sun, moon, and stars are revolve around the earth, and the other planets revolve around the sun. In the other words, Brahe's model is combination of geocentric and heliocentric model.
Thank you so much to our astronomers here sharing their thoughts about Brahe's instrument and contribution of these to astronomy. Back to you, Miss Addy and Miss Nelly.
Tycho Brahe is indeed a fascinating astronomer from history.
Absolutely. Tycho Brahe is indeed amazing astronomer. He's like the detective of the stars, unrevealing the mysteries of the universe using his remarkable instruments to explore the sky and make amazing discoveries.
Moreover, his discoveries also helped Johannes Kepler in formulating his first law of planetary motion.
That's right. So stay tuned, viewers, as we take a brief break. When we return, we'll delve into Johannes Kepler 3 laws of planetary motions, unlocking more mysteries of the cosmos.
Ding! Ang bato! Darna!
Mentos, the fresh maker.
Bakit mo pa kasi pinapatago sa akin?
Audio Jungle Stellar News.
Welcome back, viewers. Before the break, we explored the remarkable instrument of Tycho Brahe and his contribution in astronomy.
And now, let's explore to the 3 laws of planetary motion formulated by Johannes Kepler. Back to you, reporter Lance.
Welcome back, and I'm still here with astronomer Hera and the new astronomer Simon, who are going to join us. Okay, so astronomer Simon, can you introduce to us who is astronomer Johannes Kepler?
Johannes Kepler is a German astronomer. He is the research assistant of Tycho Brahe, and when Brahe died, he inherited the vast observational data of Brahe and used Brahe's meticulously collected data to formulate the 3 laws of planetary motion.
Can you introduce and explain to us Kepler's 3 laws of planetary motion?
Kepler's first law, the law of ellipses, stated that the orbit of each planet is an ellipse. This means that sometimes the planet is closer to the sun and sometimes farther away. The location or the point in the orbit where the planet is nearest to the sun is called the perihelion, while the point in the orbit where the planet is farthest from the sun is called aphelion. This law went against the prevailing belief during the time that the shape of planetary orbits is circular.
Kepler's second law, the law of equal areas, revealed that a planet switches out equal areas of the eclipse over equal time intervals. This law is based on the speed of the planet while orbiting the sun. The planet will travel faster and faster as it gets closer to its sun. Finally, Kepler's third law, the law of periods, established a mathematical relationship between a planet's orbital period and the distance from the sun. This law provided a deeper understanding of the motion of planets in our solar system. It states that the square of the period of planet's revolution is proportional of the cube of the semi-major axis of its orbit.
Thank you, astronomers. Thank you. These laws derived from Brahe's data and Kepler's mathematical analysis revolutionized our understanding of the solar system. They paved the way for future discoveries and served as a foundation for Isaac Newton's law of universal gravitation. Back to you, Miss Nelly and Claire.
Thank you, reporter Lance. The contributions of Tycho Brahe and Johannes Kepler are testaments of the power of observations, meticulous data collections, and mathematical analysis. Their work continues to inspire and guide astronomers to this day.
And that concludes our special reports on Tycho Brahe instrument and the groundbreaking discoveries of Johannes Kepler's The Three Laws of Planetary Motion. Thank you for watching.
And keep watching for more fascinating stories.
Have a stellar day,
Everyone.